Suppose we wanted to write a program which will use midpoint rule to estimate area under a curve. And in this particular case, suppose we want to estimate the area under a quarter circle curve. Of course, we already kind of know that the area of a quarter circle is basically pi r squared divided by 4. But by choosing this quarter circle area, it makes it very easy for us to check our work and test out that our program works. So we want to write a program that will estimate the area under this quarter circle curve by summing n rectangles using midpoint rule. Remember that the idea of midpoint rule is that we split our curve into n rectangles, and we calculate the area of a rectangle formed where the midpoint of the rectangle is the height of the curve at that point. So had we divided this curve into 3 rectangles, we would see that our area could be approximated by the areas of rectangle 1, 2, and 3, and the height of each of those 3 rectangles is given by the height at the midpoint x location. So one way to approach this program is to break it down into subtasks. Remember in our previous video how it can be really helpful to write multiple functions that perform the subtasks of a program, and then combine them together to get the finished program. So let's try this by breaking down our program into smaller subtasks. We can write a function that will first prompt the user to give us the radius and the number of rectangles. Then we can create a function hOfX, and that will give us the height of our rectangle at any x location. And you'll remember, in this case, we are given that h of x is just the square root of radius squared minus x squared. Next, we need to calculate the area of the nth rectangle. So we can use our function h of x and the x position of that nth rectangle to determine the area. Finally, once we know the area of one rectangle, we can find the area of n rectangles and take the sum to get our area. So let's go ahead and try writing each of these functions in C++ and see what we get. Let's first start with a void function called getRandNValues. Alright, so here's how that midpoint rule calculation could look in C++. We've declared some functions for getting our r and n values. We have a function h of x. We have a function called areaNthRectangle and a function called midpoint. So notice what we can do. We can first declare those variables to hold the radius of our quarter circle and number of rectangles that we want to use. Also, maybe some double variable called result to hold the result of our calculation. The first function we want to write is a function called getRandNValues, which will prompt the user for the radius of our quarter circle and the number of rectangles we want to use. Once we've determined those values, we can then call our midpoint rule function to perform the midpoint rule calculation. and then our main function can output the results to the screen. So let's first go ahead and try writing this function, getRandNValues. And you'll notice I'm using pass by reference here. I have the ampersand next to both of my arguments. So the reason why I want to have that ampersand there is because this allows getRandNValues to directly update rval and nval and send those values back to main. By using pass by reference, I can have one function update two values in main, so I can essentially return two values with this one function. So here I can ask my user, enter the radius of the quarter circle, and I'll take in rval. And then I can ask my user, enter the number of rectangles to use in the midpoint rule calculation. And then I go ahead and I take in nval. So once again, since these variables are passed by reference, any value copied in to rval here, that is going to be preserved in whatever variable I have back in main. So this function will update rval and nval with the values the user has provided. So we've completed our first function, getRandNValues. Let's now write our next function. We now want to write a double function called hOfX. hOfX should accept two values, the x position and, in this case, our radius r. And we want to return the value of square root r squared minus x squared for that given r and x values. So we've already declared our function hOfX in CLion, so let's go ahead and we'll copy the header so that we take the same exact return type and arguments. And now here we can go ahead and type the code that this function should complete. This function hOfX just needs to perform a square root calculation. We want to return the square root of val squared, rval squared minus xval squared. And we have included the CMath header, which allows use of the square root function. So in this case, I can say return square root of rval times rval minus xval times xval. So notice here, I could have also chosen to use the power function if I had preferred. But in this case, I'm just going to go ahead and take the square root of that quantity. So now that we have written our function hOfX, let's move on to our next function. Our next function needs to calculate the area of the nth rectangle. So this function should accept three arguments, where n is the nth rectangle that we want to find the area of. Numrect is the total number of rectangles that we want to use. Again, that's given by the user. And radius is that r value from the user that tells us the radius of our quarter circle. And we want to return the value of the area of our nth rectangle as a double. So you can see in this figure some useful information that is helpful to consider. Remember, the area of the nth rectangle that is equal to the base of our nth rectangle times the height at the x location. Well, what do we know about our base? Well, we know that our base is just going to be our radius that our user had provided divided by the number of rectangles. So in the case of this figure, we see that our base dx, that's just equal to our radius divided by 3 rectangles for the example. The next one is the x height, or the height h of x at the x location. Notice the location for the first rectangle's midpoint is going to be dx over 2, or the radius over number of rectangles times 1/2. Then the second rectangle, the location of that second rectangle is going to be dx over 2 plus dx. Third rectangle will be dx over 2 plus 2 dx. So notice the position of the nth rectangle so the x position of the nth rectangle's midpoint is equal to dx over 2 plus the nth rectangle, or basically n minus 1, times dx. So we can use this equation and plug in that x position to h of x. If we know base times the height at the midpoint, that gives us our area of the nth rectangle. So let's go ahead and code this function up in C++, and we'll see how we can use that to find the area of our nth rectangle. So let's go ahead and take area of the nth rectangle, and let's go ahead and code this up in C++. So first we need to find the width of each rectangle's base. And then that is simply calculated by dividing radius by number of rectangles. So I'm going to say let dx be my rectangle base width. So I'm going to declare a double named dx, and I'm going to say dx is equal to my radius value, which is rval, passed in from my argument, divided by numRect, where numRect is my total number of rectangles that I'm using. So I'm dividing my radius by total number of rectangles to determine the width of each rectangle's base. Next, I need to find the midpoint where the nth rectangle x, basically find the x position of the nth rectangle's midpoint. So by the reasoning that we described before, I'm going to go ahead and call it midpoint x. So as we mentioned before, using our figure and the reasoning shown here, we determined that the x position of our nth rectangle must be given by dx over 2 plus n minus 1 times dx. And now we have the x position of our midpoint. Now I know that the area of the nth rectangle, that is simply going to be equal to our base, which is dx, times the height, which in this case, our height is h of x, times, notice first we give it our x position, which is midpoint x, and then for the second argument, we give it our radius value. So here we calculate area of the nth rectangle as base dx times height, or h of x at the midpoint. And then, finally, the last thing we need to do is return that value area that we calculated. So the last step is the fun part. Now that we know how to find the area of our nth rectangle, we need to sum all n rectangles in our midpoint rule in order to find the total area under our curve. We already know how to calculate the area of one rectangle, so here we can just use a while loop or a for loop to perform the summation for all of our rectangles. So now let's go ahead and write this midpoint rule function. So once again, our midpoint rule function does accept our radius value and our number of rectangles as input arguments. So here, we need to use a loop to sum the area of all n rectangles for the midpoint rule calculation. So I'm going to go ahead and declare a double variable called sum of n rectangles. And in this case, I'm going to go ahead and start out with my rectangle n equals 1. So we want to start with our first rectangle. So notice what I can do. All right, so let's look at what we have so far. First, I'm declaring a variable to hold my sum of n rectangles, and I'm going to initialize it to 0 initially. Initially, my sum is 0. Then I'm going to start a for loop, and I'm going to say that my sum of n rectangles, that's going to be equal to my sum plus the area of my nth rectangle. So in this case, I'm going to take my n value. So first I'm going to plug in n for rectangle n. Then I'm going to plug in numRect, which is my total number of rectangles. And then I'm going to plug in rval, which is my radius. So notice I can just take my sum, and for each of my n rectangles, I can add it to that cumulative sum. So for my first rectangle, my sum will be 0 plus the area of my first rectangle. For my second rectangle, it would be equal to the previous sum plus the area of the second rectangle, and so on. So notice this for loop will allow me to calculate the area of all n rectangles up to and including the nth rectangle. And then, when I'm finished, I return the sum of all n rectangles. Notice that by writing this function area of my nth rectangle, my midpoint rule calculation became quite a bit easier because I could just call this function whenever I wanted to find the area of a given rectangle. So let's go ahead and give this program a try now that we have successfully implemented our main function. And we know that the area of a quarter circle will be approximately equal to pi r squared over 4. So if I choose to find the area of a rectangle with radius 2, I should get a value close to pi, or 3.14. So let's try running this program and see if I'm able to get a reasonable result. So here, if I say that the radius of my quarter circle is 2, and I use, let's just say, 100 rectangles, I would expect that my result for area should be pretty close to pi. And notice that's exactly what we get. And notice how it took C++ just a split second in order to sum all 100 of those rectangles. So as you saw, by writing a series of functions and putting them all together, we were able to successfully complete this midpoint rule calculation. Drawing pictures was also really helpful in order to consider the x position of each rectangle's midpoint and to understand what the calculations looked like.